out of the boundary. So the moment I reaches out of the boundary or temporary reaches null, that's when you stop. So technically what you've done is, you've taken down all the elements into an array, sorted them, and put them back into the linked list. Once that is done, you can return the head of that linked list, and that will be the same head because you're replacing the integers. So this will be the extreme naive solution. If I have to write down the pseudocode, it's going to be super simple. I'll be writing down a function which will be taking a head. Now what is my first job? The first job is to initialize an array. So I can take an array or a list which is empty. After that, I'll have to take a temporary which is pointing to head. Then I'll have to traverse through the linked list. So I'll be traversing till temporary reaches null. Now what is my first thing that I'll do? I'll take the integer, put it into an array. So I can say array dot add, and I can say temporary data or value, whatever it is. Once that is done, I can say temporary, can you move to the next? So temporary will go to the next. Done. Once that is done, I can apply quick sort or merge sort depending on your preference. So you can apply the sorting algorithm on the array. Once the sorting algorithm is applied,
100 years ago, my great-grandfather worked on a farm. Then he got replaced by robots. My grandfather went on to work in a car factory in Detroit. He got replaced by robots. My father went on to become a McDonald's chef, but he too was replaced by robots. I didn't want to suffer the same fate, so I got into programming. They said coding is the new literacy, and everyone needs to learn Python. But then Copilot started writing a little bit of code. GPT-4 started writing a lot of code. But then yesterday, Devin burst onto the scene, an AI that takes over our tooling to write code in an infinite feedback loop. In today's video, we'll find out if this little named Devin is the final death blow for software engineering, or if it's yet another hyped up pile of garbage designed to milk what's left of the VC money in this latest AI hype cycle. It is March 13th, 2024, and you're watching The Code Report. Software engineers right now are absolutely terrified, begging the developers of Devin to stop what they're doing. Human software engineers over at Cognition Labs have developed a machine that they're calling the first AI software engineer. It has access to all the same developer tooling that you do, like a terminal, a browser, a code editor, and so on. And that means it can solve problems like a real real software engineer by Googling until you find a blog or Stack Overflow answer that you can copy and paste into your code. A product manager can give Devin some requirements, and it will respond by creating a plan of action. Then it goes to the web to get some API documentation. Then it starts writing some code. Then it runs it, it gets an error, it fixes its code, and continues doing this in an infinite loop until it solves the original problem. It's similar to tools like AutoGPT, where an LLM is the base technology, but you give it the ability to perform actions and then react to the feedback that you get from those actions. Devin is already smashing other tools on the software engineering benchmark, which is a test that determines if AI can solve real-world issues on GitHub. Generally speaking, AI sucks really hard at this benchmark. GPT-4 only gets the job done 1.74% of the time, while Devin is currently sitting at 13.86%. That's a huge improvement, but a tool that can only solve GitHub issues 13% of the time is not quite good enough to replace most software engineers today, although this number will likely improve in the future. Things are going to get really lit though when tools like this start doing everything in parallel, like Google's AlphaCoder, which currently beats 85% of competitive programmers, and it does that by using an LLM to generate thousands of possible solutions in parallel, then picks the best one. In the future, you'll be able to post a job just like you would on Upwork, and 10 minutes later, Devin will come back with 1,000 different apps, and you can choose the best one. In fact, Devin is already doing real jobs on Upwork and getting paid for it. So I guess that makes it official. They took our jobs. They took your job! They took your job! Took your job! Devin can learn new technologies, it can build and deploy apps, it can fix bugs in existing code bases, train its own AI models, train its own AI models, train its own AI models, and do all kinds of other stuff. Pretty impressive, and the company itself is backed by Peter Thiel's Founders Fund, along with the Collison brothers from Stripe, and a bunch of other heavy hitters from Silicon Valley. And Cognition is not the only stealth startup in this game. There's also Magic.dev, which has been funded with over $100 million, and has a shared investor of Elad Gil, who's also made investments into Mistral and Perplexity AI. It's naive to think that Silicon Valley doesn't want to replace programmers. They absolutely do, and whoever does it first is going to make a ton of money. But there's really no point in being a doomer. For one, there's a very high probability that this technology will be like self-driving cars or 3D printing, which promise to revolutionize the world, but in the grand scheme of things never delivered on those promises. Currently, the only thing that Devin can do is bang out crappy little demos, and anyone that's used AI tools over the last year know that they're extremely useful for simple problems, but as soon as you get into more complex problems, they become counterproductive and end up hurting your code more than helping it. However, there's a lot of smart people who think that problem will be solved. Like Jensen Huang recently made this bombshell statement.
It is our job to create computing technology such that nobody has to program. Everybody in the world is now a programmer. This is the miracle of artificial intelligence.
But even if Devin succeeds and coding becomes an archaic skill, there is a solution to that depressing outcome. And that, of course, is the once daily pill I'm working on with Pfizer. It's a dimethyltryptamine-based gene therapy that rewires your brain for optimal coding performance. Common side effects may include headache, diarrhea, geometric hallucinations, ego death, and physical death. So don't let the robots take your job. Ask your doctor if getting Fireship pilled is right for you. This has been the Code Report. Thanks for watching, and I will see you in the next one.
applied. The next job is to take I equal to 0 and reinitialize temporary to head. We have to replace the integers. So maybe we can again do the traversal. So the traversal will be simple. I'll be traversing till temporary is not null. And we will say temporary value or data will be array of I. Once that is done, what is my next job? I will be saying, I will be saying I equal to I plus 1. I'll be saying temporary, can you move to your next? So temporary will go to my next. So the while loop is completed. Once that is completed, I can return down the same head because that will be my head of the updated linked list. Done and dusted. If I ask you the time complexity, it's going to be super simple. This will be taking a BGO of n. Very simple. This will be taking a n login because merge short or quick short takes n login. And again a retraversal will be taking a BGO of n. So the overall time complexity will be n plus n login plus n, and the overall space complexity will be BGO of n because you're using an extra array to store all the elements. So this will be the time complexity and the space complexity. Now this is where the interviewer will not be happy with the extra space that you're using and he'll ask you to optimize it. So the brute force algorithm was taking a space complexity of BGO of n. Now we are not allowed to use any external space. That itself gives us a hint that whatever we need to do within the linked list itself, right? So what are the sorting algorithms that you know of? The most optimized ones are, one is merge sort, while the other is quick sort. In case you don't know about them, please go back and watch it. I have videos on both of them. Please go back and watch it. You should be knowing in depth. Once you know both these algorithms in depth, you will realize that this one is easier to implement, while quick sort is slightly tough to implement. So what I will do is, I'll try to implement merge sort within the linked list itself. Got it? A quick recap about merge sort. You always take an array, you break it down into two parts. One is the left and one is the right. And you always break it down from the middle. After that, you again break it down into two parts, again from the middle. After that, you again break it down into two parts, again from the middle. Once you reach single elements, you try merging them back and you merge them into sorted. You merge them into sorted. And after that, you again merge them and eventually you get a sorted array. This was a quick recap about merge sort. In case you don't know about it, please pause this one, go back and watch it. Got it? Okay, fine. How do I implement merge sort in a linked list? It's going to be super simple. What was the first step? The first step was breaking them down from the middle. Now you have 5 elements. So obviously if I'm breaking them down into middle, I cannot do 2.5 and 2.5. So what I'll do is I'll take 3 elements on the left. I can take 2 elements on the right. You can do the other way as well, 2 and 3. That's your choice. So what I'll do is I'll take 3 pointing to 4, pointing to 2. So this is a linked list and this will be pointing to null. And the right linked list will be from 1 to 5 to null. What I've done is I've broken them down here and I made sure that this is pointing to null. Please make sure you do this so that it is an individual linked list. Now this is an individual linked list. It needs to be sorted. I'll again apply merge sort on it. So this will again be broken down into 2 parts. This time from here. So it will be 3 pointing to 4 pointing to null, and the right one will be just 2 pointing to null. So this is how the left part will look like. And you know in recursion, the left part gets executed at first. So let's do it. Again, this one will be broken down. So this time it will be 3 and this will be 4 and both of them will be pointing to null. So the left recursion will go in, right? So you have single elements. Now this will be your base case. Whenever you have single elements, you stop then and there. Whenever you have single elements, you stop then and there. So you have 3, you have 4. Let's merge them back. So I try to merge them back. So when I try to merge them back, can I say that they'll still stay as 3 and 4 because 3 and 4 are sorted in itself? Perfect. Now you have 3, 4 you have to, I've already done a previous video and I've told you how to merge two sorted lists. I've told you how to merge two sorted lists. Go back and watch it. So can you merge this list 1 and list 2 because both of them are sorted? Can you merge them? Yes, you can. So please merge them back. So once you merge them back, it will be having 2, 3, 4. Perfect. Now we will go to the right part. Now we will go to the right part because the left part is completed. The left part is completed. So we'll go to the right part. I'll give you the dry run as well. Don't worry about that. So you'll have 1 pointing to null and you'll have 5 pointing to null. Again, base case because you have 1 element. So let's return. So when you return, you'll still have 1 and 5. So I can say that the right portion is done as well. So the right portion is completed. So what will happen is the right portion will try to return and the left has already returned. So what do you have? You have a list L1 on the left. You have a list L2 on the right. Left and right. Now you can merge them. You know how to merge two sorted lists. You know it, right? We already did it. So try to merge them. So when you try to merge them, you will eventually get 1, 2, 3, 4, 5. So what you have is a merge sorted, rather what you have is a sorted list after performing merge sort. So the dry run was very simple because you already know about merge sort. Now what I'll try to do is I'll try to write down the pseudo code. Again, it won't be language specific. In case you want codes in C++, Java, Python or JavaScript, it will be given in the description. So before I write down the code, please remember this code snippet. This is directly from the merge sort of arrays. Remember this code snippet. You always take an array, low and high. This is the left point and the right point, right? After that, if it is a single element, if the left and the right point are same, it means it is a single element. You return. Otherwise, you find the middle and you break them down. So there's low, there's high. You find the middle and then you break them down to low to low to mid, and mid plus 1 to high, mid plus 1 to high. And then you call merge sort, merge sort. You call it, it comes back. You call it, it comes back. And once that is done, you call the merge function in order to merge the left half and the right half. Remember this code snippet because I'll write the exact same code, but I'll write in terms of linked list. Let's try to write it. So I'll be writing down the function and this function will be taking the linked list. Now when I say linked list, it basically means I'll be taking the head because the head denotes the entire linked list. Now in our earlier snippet of code, we always took down the array in terms of merge sort in arrays. And then low and high was used to figure out which portion of array was being sorted. Got it? But in our function, we'll just be taking down the head of the linked list. What is my first thing that I have to write? The base case. Can I say if the head is empty? What if the linked list is empty? That might be a case. That might be a case. Or what if it's of a single element? If it's of a single element, I don't need to sort it. It's already sorted. So I can straight away return the head. I can straight away return the head. Perfect. What after this? After this, I'll have to make sure that if I've been given a single linked list, I need to break it down. The first step is to figure out the
Mad.
middle. How can I do that? By tortoise and the hare algorithm. I've already done that in my previous videos. Go back and watch it. So what I'll do is, I will be calling find middle. Find middle. I'll be
एक मिनट.
passing on the
आंसुओं को लेके तुम कहाँ को चल दिए, तुम ऐसे तो न थे। मेरी किताबों के वो फूल जो तुमने दे दिए, अभी भी वो महकते हैं तेरी याद में, तेरी याद में, अभी भी वो महकते तेरी याद में, ये तेरी याद में। अभी भी वक्त है, अभी भी तुम हो, अभी भी हम हैं, अभी भी लब है, अभी भी जान है, अभी भी दम है। तो दिल पर अंगार जला दे, जुल्म की अब एक दीवार गिरा दे, माना सब ढोंगे जाना बस बातों के हैं ही तो हम अदाकार बुला दे। अरे बस दिल है तोड़ दो, तुम मेरी खामोशी का शोर हो, मैं लिखना ही छोड़ दूं उस दिन जिस दिन तुम सुनना ही छोड़ दो। तुम मेरे ख्यालों की मलकियत जाने अगर अब हकीकत कुछ और है, वो मेरी वफाओं के लायक नहीं क्यों अब लगता जफाओं का दौर है। कागजों की कश्ती, वो अश्कों का समंदर, वो सब किताबी बातें कहाँ हुए मुकम्मल। झांकू मैं कमरों की खिड़की से बाहर, सूजी आंखें बिखरे बाल, the more you look the less you see। हाँ जिंदगी अपनी खुशी से जीना, फिर किसी गली में महकते होगे तुम सियाही में बसे हो कागजों पे गुम। मीलों का सफर है, ठहर जाओ ना तुम, मैं पूछता हूँ कहाँ चल दिए। तो फिर बताओ ना कि आंसुओं को लेके तुम कहाँ को चल दिए, तुम ऐसे तो न थे। मेरी किताबों के वो फूल जो तुमने दे दिए, अभी भी वो महकते हैं तेरी याद में, तेरी याद में, अभी भी वो महकते तेरी याद में, तेरी याद में। हिजर की शब हम बदम याद आए थे तुम, दिए जख्म हर कदम बहुत सताए थे हम रहे ना रहे कौन सा किसी को हम, दरअसल हम फिक्रमंद तेरे लिए इस जन्म, कट रही जो रातें मेरे तेरे दरमियां में, इनमें तुम कहाँ ये ढूंढे अभी तू जहाँ है। बात इतनी सी ये रातें तेरे बिन वीरा है, इनमें जलती रोशनी भी थी तेरे गुजारे, हम नशे तुम्हारी बातों से ही था सहारा। आसमां दिखा के तुमने क्यों ज़मीं पे मारा, उम्मीद दे चुके थे कितनी एक दूसरे को, हम दोनों एक हैं सिवा तुम्हारे नहीं गुजारा। Wish I could make it alright, but you know हमारे बस की बात ही नहीं। I'm not complaining, इस दिल को दर्द है अब जो तेरा साथ नहीं। तो फिर बताओ ना कि आंसुओं को लेके तुम कहाँ को चल दिए, तुम ऐसे तो न थे। मेरी किताबों के वो फूल जो तुमने दे दिए, अभी भी वो महकते हैं तेरी याद में, तेरी याद में, अभी भी वो महकते तेरी याद में, तेरी याद में।
यानंतरची बातमी आहे पुण्यामधून।
शुभम जाधव अर्थात आघाडीचा मराठीतला रॅपर रॉकसन
शुभम जाधवच्या विरोधात गुन्हा दाखल करण्यात आला।
ये दुनिया झुकाने चली सिर मेरा, मुझे समझेगी ये मेरे मिटने पे। आजकल तूफानों से घिरे घर मेरा, तो मैंने आसमां भी ला दिया है घुटने पे। मेरे खौफ से ठसती है बड़ी बड़ी हस्ती, में खुद की तारीफ ऐसे करता नहीं। खड़े खड़े चलती है सड़कों पे मस्ती में, कुत्तों के गली से गुजरता नहीं। आजकल गाड़ी मेरी जहाँ पे भी रुकती है, दुनिया सीधे कदमों में झुकती है। लोग घुटनों पे आके मेरे हाथ चूमते हैं, लड़कियां सर पकड़ के चीखती है। गर्दनें सूखती है अपोजिट की देख के मुझको, जब काफिला रॉकसन का चलता है। बड़े बड़े हथियार रखते हैं, नाम सुन के मेरा बड़े बड़ों का कलेजा हिलता है। दरवाजा खुलता है नरक का आवाज से, मेरे पूरे कायनात पे है मेरे कलम का राज। मैंने मौत के छाती पे मौत लिख दी, मेरे कदमों पे गिरा उसके सर का ताज। ये दुनिया खिलाफ हुई तो रॉक संगटा मिलेगा, झुकेगा नहीं ये सर लेकिन कटा मिलेगा। हालांकि दुनिया बंदियों के पीछे पागल है, लेकिन ये बंदा अपने माँ पे मर मिटा मिलेगा। तूफानों के घेर में सवार हूँ मैं नाव पे, जान की क्या कीमत है जब स्वाभिमान हो दाव पे। सपनों पे मैं लपका, जख्म से खून टपका और आग की लपट की पट्टी बांधी हमने घाव पे। मैं लोगों के नजर में हैवान बन गया हूँ, इंसान के शक्ल में भगवान बन गया हूँ। जान के दुश्मन की मैं जान बन गया हूँ, कदम चूम मेरे में महान बन गया हूँ। माझी हिपहॉपची कला मला भावणार आहे, तुम्ही अजून काहीच नाही बघितलं मी लय धावणार आहे। मला शोधून दाखवायचं कोण सज्जन आहे, गाण्यात शिव्या देतो म्हणजे मी काय निर्लज्ज नाही। माझा विद्रोही आवाज कुणी दाबू नाही शकणार, माझ्या विरोधात किती पण मोमेंट करा। माझं मराठी रक्त अख्खी काय ना झुकवून तुम्ही घरात बसून माझ्यावरती कॉमेंट करा। तू काय मारणार मला, मी तर मरण चुकवलं। झुकू नको मला छत्रपतीनं शिकवलं, माझ्या रक्तात भिनतो मित्रा गणिमी कावा। माझ्या विद्येनं मी अख्खं विद्यापीठ झुकवलं। माझी गाणी कॅलिफोर्निया मध्ये धुडगूस घालतात, तिथल्या हुडवरनं मला सरळ सलामी येते। त्यांच्या विचारांना लागली फक्त लाचारीची सवय, त्यांच्या वाट्याला फक्त गुलामी येते। मी मंत्री झुकवण्याची ताकद ठेवतो, माझं राईट आणि लेफ्ट विंगची घेणं देणं नाही। माझ्या हातामध्ये फणफण ते सत्याची ज्वाला, माझं जातीची आणि धर्माची पण घेणं देणं नाही। माझी चालते ना मंत्रालयात चर्चा, मी पण हलवल्या ना पार्लिमेंटच्या खुर्च्या। लय जणांनी प्रयत्न केले तरी माझी वाकडी नाही झाली, जाऊन खोला माझ्या विरोधात मोर्चा। हो मी माझा खंबा बसवतो आणि ऑपोजिट ठसवतो, त्याचं वागणं पण असं काही गैर नाही। माझ्यासोबत फाटू नका उग नाही तर जात चाल मोकार, बाकी माझं कोणासोबत सुद्धा वैर नाही। ही जगदुनियानं लाखी गुडघ्यावर, कारण माझा हो मी माझ्यावरती जीव वाळून टाकतो। माझ्या वाढदिवसा दिवशी नांग्यात तलवारी नाचत्यात, आम्ही ठोकत नाही तोडत नाही जाळून टाकतो। मारल मरण मिठी कारण मी सत्य लिहितो, मी यमाच्या बी छातडावर मृत्यू लिहितो। माझ्या तिरडीवर तुम्ही लोक असू नका ढाळू, मी कागदाच्या आत्म्यावर पण तथ्य लिहितो। यांच्या कानात एक आणि तोंडात एक दिलाय, अंडरग्राऊंड हिपहॉप मी मेन स्ट्रीमला नेलाय। मला 10 तोंड नाहीत पण मी रावण आहे दोस्ता, माझ्या आतमधला माणूस तर कधीचाच मी आलाय। माझ्या कलेसाठी छातीवरती गोळी घ्यायला तयार आहे मी, पोरींच्या हृदयामध्ये झालेलं एक भुयार आहे मी। या समाजातनं मला आधी जात मारायची आहे, तुझ्या सिंहासनाला मला लाथ मारायची आहे।
कारण मुद्दा असा आहे की शिव्या देणं हा जर गुन्हा असेल ना, मी परत एकदा म्हणतोय, शिव्या देणं हा जर गुन्हा असेल ना, तर आपल्या महाराष्ट्रात नाही भारतात चौक्या कमी पडतील गुन्हेगार आतमध्ये टाकायला।
तुझ पे किया मैंने खुद से ज्यादा भरोसा किया, तेरे खातिर अपने आप से खुद मैंने धोखा। वारती कमाई तुझे मानता था भाई, बोल तुझे कभी मेरी किसी चीज के लिए मैंने टोका। किसी बात पे नहीं ना तुझे मैंने बोला, बदले में क्या मिला दिल तूने मेरा तोड़ा। मेरे प्यार का क्या बनता था ये सिला, मुझको गिराने लगा जैसी मुंह मैंने मोड़ा। इतना गिर जाएगा नहीं था कभी मैंने सोचा, क्या करेगा पे तू इन सारे पैसों का याद आएगा पछताएगा। जब कोई मुश्किल में साथ देने वाला नहीं कोई तेरे होगा, मार देना चाहिए तुझे इसी वक्त तभी होता जिंदा नहीं तू। बदला मुझे लेना होता, माफ किया तुझे मगर भूलूंगा ना कभी। मुझसे दूर रहना ही भला तेरे लिए होगा, खुश रखे तुझे मौला पूरे तेरे घर को। जान प्यारी तुझे मौका दिया मैंने घर को, मुकाम हासिल करने को मुझे लगे परसों। बदनाम करने चले मुझे देख के अब तरसो, तुम पीठ पीछे वार करो साले नाम मर्द हो तुम, ऐसे कभी किसी से नहीं जीत सकते। अमीर या गरीब ये तो किस्मत पे, किसी का नसीब थोड़ी छीन सकते। कहते मेहनत और दुआ से तकदीर पलटे, दिल तोड़ने वाले को रब जलील करते। मैं नहीं तेरा बदुआ ये हकीकत है, हर चीज की एक कोई ना कोई कीमत है। आगे तेरी मर्जी है जो भी चुनना है, तूने क्यों किया ऐसा मुझे नहीं सुनना है। मैंने फिर से कभी अगर कहीं देखी तेरी शक्ल, अपने हाथों से कर दूंगा तेरा वहीं पे मैं कत्ल। Don't call me a brother, don't call me a brother, don't call me me a brother. Motherfucker, don't call me a brother. Don't call me a brother. Don't call me a brother. Motherfucker, don't call me a brother. Don't call me a brother. जिसके लिए जान दाव पे लगाई वही यार मेरे आज मेरी जान लेने आए. लगे कोई एतबार के न लाए, क्या पता कब कौन किधर क्या कर जाए. ऐसे देख के हालात मुझे रोज लगता है वक्त अब करीब ही कयामत का है. किसी दिन दरवाजा तेरा मौत खटखटाए, बोले मिलने को तुझे ऊपर रब ने बुलाए. जैसे खाली हाथ आए वैसे खाली हाथ जाए, जैसे बीज बोए तूने वही फल खाए. पैसे होके बिना चैन तुझे एक पल लाए, तुझसे अलग मगर तरस तुझे देख कर रहा है. मुझे दुख होता है मगर मेरा नहीं कसूर, जानता है मुझे होने से पहले मशहूर. ऐसे देखता है जैसे सब भूल गया तू, जब बचाने के लिए जान तेरी किया मैंने खून. बोल मुझे अगर के मैं झूठ बोल रहा हूँ, साले आजा मेरे पास सारे पड़े हैं सबूत. तुझे तेरे बच्चों के लिए छोड़ रहा हूँ मगर देखना दोबारा नहीं मैं चाहता तेरा मुंह. सीख अपनी गलती की लेना जिम्मेदारी तेरी, या ना तुझे रोकती है मांगने से माफी. तुझे लगता है दौलत ही सब कुछ है, मुझसे कमा के तेरा मुझको तू गाली बहुत सुन ली है मैंने तेरी. चुप पड़ वे, तूने दिल से मेरे इज्जत अपनी खुद सारी गवा दी. तेरी जिंदगी एहसान मेरा तुझ पर है, मत करना तू यारी अगर आती ना निभानी. मुझ पे तेरी बातों का नहीं होना अब कुछ असर, रख लिया जैसे मैंने दिल पे ये पत्थर. वहीं कर दूंगा दफन तेरी खोद के मैं कबर, अगर कभी कहीं आया फिर तू नजर. Don't call me a brother. Don't call me a brother. Don't call me a brother. Motherfucker, don't call me a brother. Don't call me a brother. Don't call me a brother. Motherfucker, don't call me a brother. Don't call me a brother.
Alone together, just you and I. God has made us.
आया है खत मेरे नाम लेकिन उस पर किसी का नाम नहीं है. अब पढ़ना शुरू किया तो पता लगा कोई आम पैगाम नहीं है. लिखने वाला कहता है उसने गाने सारे मेरे याद कर लिए. I'm thinking it's kind of funny, मुझे अपने भी सब गाने याद नहीं है. लिखता है 2012 में पहली दफ़ा उसने मेरा कुछ सुना था, तब मैं शायद 15 का था. उसका कहना है कि वो था तब 16 का. वो लिखता है आज के दिनों में उसकी खुशी का ठिकाना ही नहीं. मेन स्ट्रीम ये स्ट्रीम वो स्ट्रीम, मेरे से हार्ड कोई आना ही नहीं. मैं सोचता हूँ why do they think मेरे जैसा ना आने में मेरी कोई जीत है. जो मुझसे मुतासिर रहे मुझे उन लड़कों से बेतहाशा उम्मीदें. मैं समझता हूँ तेरा पर्सपेक्टिव पर मेरा पॉइंट ऑफ व्यू थोड़ा सा फर्क है. I came from nothing, जान लगा दी, हसल के मामले कड़क हैं. खैर ये मेरा एक मौक़िफ़ है, even if you don't fuck with it तो chill है. दिल से बड़े ख्वाब मेरे ख्वाबों को ताबीरें तुमसे ही मिले. जब कोई ना खड़ा था पीछे ये कला ही तो मेरी गवाह बनी. Cause daddy was in and out और उस दर्द की शायरी दवा बनी. Now dad is fucking proud, उसके नाम के नारे पड़े यहाँ शोज पे. He was one of those guys जो कहता था बेटा तू ये काम छोड़ दे. अब मैं भी नहीं ढूंढता कमी उन रिश्तों में, खुदा ने कितना नवाजा है. खुदा ने वो ताकत दी मैंने लोगों की सोच को ही बदल डाला है. वो लिखता है जिंदगी उसकी भी बदल के गुजरे हुए सालों में. वो कहता है जिम्मेदारी बढ़ गई, कमी होती जा रही यारों में. वो कहता है उसके 3 भाई, वो खुद सबसे बड़ा है सारों में. लिखता है उसे हौसला मिलता है मेरे गाए हुए इन गानों में. मुझे सच्चाई दिखे इस लिखाई में, वही सच्चाई जो दिखे इस भाई को मेरी लिखाई में. सी दैट्स द एनर्जी ब्रो, खुदा हमें किसी भी शक्ल में मदद भेजता है, वी नेवर नो. तो देखो तो तब भी हम दोनों ही थे और देखो तो अब भी हम दो. वो लिखता है if he could afford वो मेरे शो पे आता next week. And I just adore the way this brother has set straight his priorities. और हाँ प्रायोरिटीज, अब मैं अंदर ही अंदर हंसूं जब वेटर पूछे कोक या पेप्सी. अब देखूं ये खत तो मुझे ये लगे मेरी जिंदगी का अक्स ही. कभी सोचा नहीं था जो दिन मैंने देखे वो दिन भी मैं देखूंगा. कभी सोचा नहीं था कि वो रो देंगे पढ़ के जब मैं उन पे लिखूंगा. कभी सोचा भी तो ये गुमान हुआ कि हाँ कहीं तो पहुंचूंगा. Never thought backstage खड़ा चोरी छुपे ये आंसू पहुंचूंगा. Life is amazing, आंखें खोल this shit is so crazy. Just when I think that I've seen it all, I see some shit that amaze me. जिंदगी बदल दी मेरी तुमने मेरी नजर से देखो तो खुद को. वो लिखता है मेरी तरह काफी अकेला महसूस करता था खुद को, लेकिन फिर अड़ जाना सीखा, हिम्मत बांध के जो लड़ जाना सीखा. और लड़ना भी ठीक था, कहीं जज्बात काबू कर लेना भी ठीक था. लिखता है उसका छोटा भाई कहता है कि वो भी रैपर बनेगा. He says वो वीडियो बनाएगा, उसका गाना भी टीवी पे चलेगा. उसके टॉप 2 में सैवेज और जानी वो फीचर करेगा तो उनसे करेगा. But bro, you better not tell him कि छोटे तुझे रैप से कुछ नहीं मिलेगा. Cause that would be fucking wrong. मैं ये लिखते हुए हंस रहा हूँ और मैं हंसा मतलब shit is serious. जिंदगी अपनी terms पे जीनी है. I'm glad that you fuck with the music. दिल से करता हूँ, got my heart into this. And I wish I could write more, but I got a show cause I'm on tour. Gotta bounce man, hang tight, be safe, bye ये तू.
मेरी फिक्र करना छोड़ दो, प्लीज मेरी फिक्र करना छोड़ दे। यार तेरा जी लेगा जैसे भी हालातों पर दिखेगा नहीं कभी तुम्हें शोर में। प्लीज मेरी फिक्र करना छोड़ दो ना, प्लीज मेरी फिक्र करना छोड़ दे जी। यार मेरे पूछते तू ठीक है ना, मैं भी हंस के कह देता रिपोर्ट ओके की। हाँ मैं ठीक हूँ, ज्यादा मुझे पड़ता नहीं फर्क, बड़ा ठीक हूँ, सुधार नहीं पाया कोई शख्स। हाँ अजीब हूँ, नहीं देता ज्यादा किसी को भी वक्त, अगर दे दिया तो खुद पे लगाऊंगा क्या, बांट दिया सब तो फिर खाऊंगा क्या, ऐसा सोचा तो नीचे ही जाऊंगा ना। ये बात पार्टीज आई डोंट लाइक इट भाई, तू गम में बुलाएगा तब आऊंगा ना। टाइम से बड़ी कोई इन्वेस्टमेंट नहीं, फिर फर्क नहीं पड़ता कि पेशा क्या है। तो उठना बेटा क्या घर नहीं चलाना है, अब तक तू बिस्तर पे लेटा क्या है। जैसे दोस्त है ना दुश्मन ये नींद भी है, इन्वेस्ट इन योरसेल्फ वक्त कीमती है। I'll be most consistent you'll ever witness, मुझे अपने से ज्यादा फिक्र सीन की है। कहीं वैक ना हो जाए, कहीं डैड ना हो जाए, किसी लड़के का मुझसे बेहतर रैप ना हो जाए, ट्रैप भी हो जाए मुझसे ब्रैक भी हो जाए, जब पंचेस का मूड बूम बैप भी हो जाए। ड्रिल भी करा है मैंने बिल भी भरा है, जज्बात जैसे भी हो कलम डट के चलाए। ये लिखाई मेरी नहीं है मोहताज किसी शख्स की, दिखाई नहीं देता क्या नहीं हूँ मैं वक्त की, प्रूव नहीं कर सकता बार बार मैं बोल बोल के, होगा यकीन तभी होगा जब टॉप पे सुधर रहा होता हूँ, जब होता हूँ गायब तुम ये मत समझना कि आऊंगा नहीं लौट के। ट्रेजेडीज 110 मेरी लाइफ में, एनिमी आकर सब बने माइक पे, वनबीज इनका मुंह तोड़ दूं, ये लिखाई मेरी जिंदगी में कैसे जोड़ दूं। वेटिंग फॉर द बेटर मी अब इतने टाइम से, हेटिंग फॉर नो रीजन, अब क्या सबको टाइम दे। जाना है सबसे आगे, लेना है सबसे कम ही रेस्ट, था ही नहीं तू कल तक आकर क्यों करे सजेस्ट। ये 2 3 4 मेरे काम के नहीं है, आई एम बॉर्न टू बी नंबर 1। याद आया नंबर से कॉल कराऊं 2 दिन से क्यों तेरा नंबर बंद। फिर से क्या दुनिया से जंग हो गई, फिर से क्या दुनिया से तंग हो गई, या जिसके लिए दुनिया से बात करना बंद की उसी से क्या बात होना बंद हो गई। समझ सकता हूँ मैं सिचुएशन तुम्हारी भी, होता ही आया है सालों से यही, वक्त दिया सब दिया मुंह कैसे फेर लिया कह दूं मैं अब तक सवालों में वही। सीखा है वक्त से कि वक्त को भी वक्त दो, फिर वक्त पे तुम सबको छिपा लोगे भाई, भागने की करोगे वक्त से भी आगे तो वक्त से ही पहले तबाह होगे भाई। इसमें शक क्या है बोल, मेरे बिक रहे राज तेरी इज्जत के बदले तो 2 ज्यादा खोल। इज्जत आते हुए लाती है हेट और ट्रॉल, बनना है बेस्ट ये सब झेलना पड़ेगा, कदम रख दिया गेम में अब खेलना पड़ेगा। सब छोड़ देंगे होप कहेंगे नहीं है कुछ स्कोप, तुझे अपना भी घर शायद जेल सा लगेगा, लेकिन चुप रहना बिल्कुल अगर प्रूफ करना गलत, जबान कम चलाना अगर दिखना है अलग। तू बेहतर है सबसे तुझसे ऊपर नहीं कोई, माइंडसेट बस इतना सा ला देता फर्क। माइंड को करना है ट्रेन इस कदर के आ ही ना पाए कभी थॉट कोई वैक, रुकूंगा नहीं कभी झुकूंगा नहीं भले हिट ना हो आने वाला एक भी ट्रैक। प्लीज मेरी फिक्र करना छोड़ दो, प्लीज मेरी फिक्र करना छोड़ दे। यार तेरा जी लेगा जैसे भी हालातों पर दिखेगा नहीं कभी तुम्हें शोर में। प्लीज मेरी फिक्र करना छोड़ दो ना, प्लीज मेरी फिक्र करना छोड़ दे जी। यार मेरे पूछते तू ठीक है ना, मैं भी हंस के कह देता रिपोर्ट ओके की।
Are you gonna listen when I talk? मैं शहर से दूर तो vibe off, मैं खुद से ही पूछूं कि क्या है खौफ, मैं खुदा से पूछूं कि क्या है मौत। अब रात के बज चुके 2:30, हसास मैं सोचें भी साइको, वो पास नहीं तभी तो eyes close, वो खास वो मेरी ये high zone। Baby तू lady and I'm dumb, I love that you love me when I don't, मैं इधर से उधर when I'm home, anxiety के टूटते cyclones, वो कर रही calls but I'm gone, I swear मुझे पता नहीं कहाँ है phone, she thinks that I'm fucking a side hoe, I am but I do wanna kind of। वो तंग मेरे नशों से, वो तंग मेरी चरसों से, वो समझती नहीं है ये, मैं तंग बैठा बरसों से, और सोया नहीं परसों से, मैं नफ्स के लफड़ों में, मैं शख्सी वो नहीं हूँ अब, किस कफस में पकड़ोगे। माँ तेरे कदमों में जन्नत और मैं तुझसे दूर एक दोज़ख में।
Head of the linked list, and this will be giving me the middle. So which one will be the middle? This one will be the middle. If I ask you which is the left linked list, you'll be like, this one is the left linked list. Can I say the head? Can I say the head denotes the left linked list? It denotes. But which one is the right linked list? Middle dot next. Middle dot next denotes the right linked list. Perfect. So I can say, okay, I know one thing, left head is my head. And I know one thing, right head is nothing but middle dot next. Perfect. So I know now the left portion and the right portion. What is my next job? My next job is to make sure this linked list is separated from this one. So I'll be making sure that the middle points to null. So I'll be doing that. My middle next will be pointing to null. Done and dusted. So what have I done? I made sure that this is pointing to null. So I have a left, I have a right. I need to call them. I need to call the merge shot again. So I'll be going ahead and calling this function that is merge shot again. So I'll be calling merge shot with the left. So the left will be left head. I'll be calling with the right, and the right will be right head. Perfect. But when I call this, it will be returning me a sorted head which contains the left portion. So I can say that the sorted head can be reinitialized to the left head, and the right sorted head can be reinitialized to the right head, because this one will also call and come back. Done. If you look at the snippet, we've already done up till this. The middle was done by finding the middle. After that, it's a similar snippet. What is the last step? To combine the left and the right. To combine the left and the right. So this is what we will do. We will go ahead and say, hey, merge two. And we have already done how to combine two sorted lists. So please go back and watch it. So merge two, left head and right head. I'll again be calling it. This will be returning me a head. So I'll be returning this one. Remember one thing, in linked list, you will have to write return. In your array, you never did write return. Why? Because the array was reference based. So whatever changes you did, it was done on the memory location itself. In the merge shot for linked list, you need to return the head of the updated linked list. That is why you will be returning whatever is returned. So please make sure you do it. In case you want to understand the dry run for this code, please go back to my merge shot video and watch the dry run on merge shot. You will understand that in depth. If you understand that, you will be understanding this as well. Take a pen and paper, do a dry run. This will get into your head. So before I move on to the code editor, there's one slight edge case that I will be talking about. Now we are using find middle in order to find the middle. Now on the back, it uses tortoise and the hare algorithm. Now tortoise and hare algorithm, whenever the length of the linked list is even, it always returns the second middle and not the first middle. But in terms of merge shot, I'm asking you which one is the middle. It'll be like you need to break it over here. So you need middle to be pointing here, so that you can straight away point this to null, and this will be your left portion, this will be your right portion. Correct? Please make sure that you modify the tortoise and hare algorithm slightly so that you get the first middle and not the second middle. It's super simple. I'll be showing you in the code editor. So time to get back into the code editor and check out the code. So if you look on the first line, very simple. After this, finding the middle. Now this is the tortoise and the hare algorithm, but there's a slight change. If you look at this, in tortoise and hare algorithm, slow pointer and fast pointer always stand at the head. What I've done is I made sure that the fast pointer is standing one place ahead, that is at head dot next. Why have I done that? I was talking about an edge case, right? I want the middle to stop at the first middle. I want middle to stop over here, right? I want middle to stop over here. That is why I've made sure that the fast pointer is one place ahead, so that it stops one place behind. You might think, will it work for odd length? It will work. You can take some examples and do a bit of dry run. It will work. So this is the only change you need to do. And apart from that, you do the same thing, and the left, the right, and then you call the merge to list. Again, I've done this in the previous video. Go back and watch it in case you haven't seen it. So this is the entire code. If I go ahead and click submit, it will be submitted. So it is time to discuss the time complexity. But before I move on to that, Let's understand the time complexity of merge sort in arrays. It was n log n, and the space complexity was big O of n, which was an external space that we were using, right? The time complexity n log n was because the height of the tree or the recursion depth was logarithmic of n, right? And at every step, we're doing a merge operation that was taking a big O of n. So thereby the overall time complexity was n log n. Over here, remember, the mid was not taking any time. The mid was not taking any time, right? And the extra space was because we were using a third array in order to merge two left and right arrays, right? That was the time complexity and space complexity. Over here, what will be the time complexity and space complexity? One thing we know for sure is the height or the recursion depth will be logarithmic of n. That's very sure. Basically, this depth will be logarithmic of n. We know that for sure. We know one thing for sure. The merge 2 is also taking big O of n1 plus n2, near about 10. So I can say that logarithmic of n into n is something I'm very sure about, right? Why n? Because at every step I'm doing a merge 2. But am I doing something extra? I think I'm doing. Finding the middle. Now over here, finding the middle is not done in constant time. It's taking a big O of n by 2 time. So what I can say that the time complexity over here is logarithmic of n into n plus n by 2, because at every step we are applying n by 2 and a big O of n for this one, right? And logarithmic of n is the recursion depth. So I can say that the time complexity is near about logarithmic of n into n plus n by 2. That's n log n. That's around n log n. But the extra space is big O of 1. Why? Because I'm not using any extra space. We know we can merge two sorted lists in place. We know that. We have done that in our previous videos. So the time complexity and the space complexity will be this one. So that will be it for this one. I hope you've understood everything. And if that is the case, please do consider giving us a like. And if you're new to our channel, what are you waiting for? Hit that subscribe button. And with this, I'll be wrapping up this. Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So this is another lecture from the Strivers A to Z course. In case you're for the first time here, this is India's most in-depth DS Algo course. Why do I say that? Because this course has 456 modules and we will be solving more than 400 plus problems in this particular DS Algo course. You can buy any of the paid courses on the market. You can check out all the free courses on YouTube. Sort. It is nothing but one of the other sorting algorithms. You must be thinking, but Striver, till now you have taught us bubble sort, insertion sort, selection sort. So why this another algorithm? Now, if you remember, all of these three algorithms were taking big O of n square in order to sort an array. This is where merge sort is better. Merge sort takes a much better time complexity. We will be discussing the time complexity at the end of this video, but as of now, you need to understand that merge sort is a much more optimized sorting algorithm. Now, you know, sorting algorithm is nothing but it will sort a given data structure. If it has numbers, it will sort it according to numbers. If it has characters, it will sort it according to characters. If it has strings, it will sort it according to these strings. So as of now, we know that merge sort is a sorting algorithm. So what will be the flow of the lecture? The flow of the lecture will be, first I'll explain the algorithm completely, then I'll go to the pseudocode, and since this is a recursive algorithm, I will go to dry run the recursion so that it gets into your head. So after this three steps, you will be able to code this particular algorithm in any of the languages, because I will be writing the pseudocode. Post this, I'll be taking one of the languages and I'll be writing the main code. Again, this is something which is not that important. I will be focusing more on the first three steps. So without waiting, let's get started with the first step, that is the explanation of the algorithm. So in order to explain the algorithm,
लोग करते हैं बातें
I will take this particular example of an array which has a size of 9. You need to remember two words. In merge short, please remember that the algorithm means divide and
and conquer
merge. Please remember this, divide
and
and merge.
merge.
So as you can see that this array consists of 9 elements. If I have to ask you a question, how do you divide 9 elements into two parts? You'll be like, okay, there are two ways in which I can do it. One is I'll say four numbers and five numbers. That's one of the ways. The other way you can say is five numbers and four numbers. So that's two ways in which you can divide 9. Why? Because 9 is a odd number. So that cannot be splitted into two equal parts. That's why either you have to go 4 by 5 or 5 by 4. Now you can follow any of the path. I will follow the 5 by 4 path. So if I follow the 5 by 4 path, what happens is this algorithm divides the array hypothetically. Very important word. This algorithm divides the array hypothetically into two parts and says 3 1 2 4 1 and 5 2 6 4. What do you mean by hypothetically? When I will write the pseudocode, I'll explain you. Okay. So as of now, this algorithm has divided the array into two parts. One which has 5 elements and the other which has 4 elements. I can say left part and the right part. Now what I will do is I'll always take the left part and I'll try to divide it again. So let's try to
Recursion
divide
में
it
always
again.
take the
If I
first
try to
part.
divide it again,
एक
what
मिनट
happens
भैया
is it has 5 numbers.
जब recursion होती है और जब partition हुए लेफ्ट पार्ट और राइट पार्ट तो लेफ्ट पार्ट के ऑपरेशन सबसे पहले होगी recursion में यही होता है.
Remember this, it has 5 numbers. So you can divide it like 2 by 3 or 3 by 2. Now since in the first step I divided 9 into 5 and 4, bigger, smaller, I'll follow the same pattern. I'll follow the same pattern so that I can easily write a repetitive code. Now what I'll do is I'll try to divide it something like 3 1 2
2
and
and
4 1.
4 1.
Remember one thing, you can also divide it as smaller, greater. That is completely okay. How you divide it doesn't matter as long as you divide it. Okay. But make sure you follow the same pattern. Like over here, it was like over here, if you see it was 5 4, that is greater, smaller. So follow the same pattern of division in the future as well for odd numbers. Okay, so next 3 1 2. Go ahead and divide it. I follow the same pattern and let's say
3 1
3 1
and
and
2.
2. So it's like 2/1. Again, I'll try to divide it. And this time, it has two numbers. It's even. So it gets divided into two equal parts. So I'll divide
3
it something like 3
and
and
1.
1. Now, tell me one thing. Can this be divided further? The answer to that is no, we
No.
cannot, because it's a single number and you cannot divide a single number. So, this is where you stop. You say, the moment I get a single number, I stop. And you perform the second half of the algorithm that states, please merge them. So, what do you mean by merge? It is 3. So, I'll write 3. It's 1. So, they are basically two hypothetical array consisting of 1 numbers. So if there are two hypothetical arrays of 1 numbers and I want to make it a single array, what will I do? I'll say, okay, let's merge it. And you try to merge it
We will
into a
compare
single
both
array
the
consisting of these two
elements
numbers,
and
but in
we
a
will
sorted way. So if I have to say, okay,
put back
I have 3,
into
I have 1.
our array.
And if I have to fill the first position, I have to make it sorted. Whom will I take? Will I take 1? Will I take 3? The answer to that is I will take 1. So I take 1. Next two is remaining 3. So I've merged it. I'll explain merge in detail as the array gets bigger. But as of now, what you can say is, okay, we come back. We come back. Whenever it's a single element in both sides, we come back, we take them, and we merge. And on merging, this will become 1, 3. This will become 1, 3.
1 3.
Perfect. Now, this 3, 1, 2 was divided into this portion and was divided into this portion. Can I say the left portion got itself sorted and now the right portion has a single element? Can a single element be further divided? The answer to that is no. So your next step will be very simple. You will take 1, 3 and 2. So can I say these are two hypothetical arrays? One is 1, 3 on the left, one is 2 on the right, and you'll try to merge them into a single because there are two hypothetical arrays. And if you carefully observe, the left array in itself is sorted and the right array in itself is sorted. So now I will go across and hypothetically try to merge them. If I try to merge them, they will give me 3 elements in the sorted order. Now tell me one thing. Do you take 1 or do you take 2 in order to fill this first position? It'll be like, hey Striver, I will take 1. So you took 1 and you did not take 2. So the moment you've taken 1, the next you will say, do I take 3? Do I take 2? Like I'll take 2. So you took 2. Next you're just left with 1. So you will take 3. Again, I'll explain this algorithm in depth. Do not worry. So we basically merge them. Again, merge them. So we get 1, 2, 3. The merging has completed. So can I say, initially when I went to the left, we had 1, 2, 3. And when we went to the right, we had 4, 1. So the left portion has divided and merged itself into a single sorted array. It has. It's time to go to the right. Let's go to the right. So the moment you look at the right, it has 4, 1. So we again try to divide it. So if you try to divide it, it will be 4 and 1. Can I say we can stop over here because they are single elements and they cannot be further divided? Yes, we cannot further divide them. So what we do is we stop. Now, if it is 4, if it is 1, and if you have to merge them into a single sorted array, first 1 will come, then 4 will come. So what will happen is they will try to merge them and you will get 1, 4. So can I say that this one went, got it sorted, this one went and got it sorted. So basically, now they both will come back because the left half is sorted and the right half is sorted. If both of them are completely sorted, what will happen? So can I say it went left and it got itself sorted? It went right, it got itself sorted. And it's time to come back. So they will get merged. Very simple. So let's write it again. 1, 2, 3 and 1, 4. And they will try to merge themselves into how many elements? Definitely, yes, 5 elements. So let's kind of now try to get into the algorithm. Now you know this is the smallest element on the left half. If I say there are two hypothetical arrays, can I say on the left the smallest element is definitely on the beginning because both the arrays are sorted. So we will take one. We will take one. We have one over here. We have one over here. If I have to ask you, which one will occupy this? It can be any of the ones. If I take any of the ones, and maybe I'll just move it. Now, if I have to ask you, out of two, out of one, which will occupy this? You know the answer. It's one. So you now move the pointer. Next, if I ask you, out of two, out of four, which one will occupy this? You will be saying two. So I'll move the pointer. Next, if I ask you, out of three, out of four, which one does occupy this particular guy? You'll be like three, and this will move out. Next, if I ask which one will occupy this, you'll be like four, and this moves out. So apparently, you got this entire thing sorted. So can I say this will become 1, 1, 2, 3, 4? Done. So this half is sorted. So we started with 9 numbers. We splitted them into 5 on this side, 4 on this side. 5 guys have been sorted. By the algorithm divide, 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 and merge, 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 they got themselves sorted. Now it's about these 4 elements. Can I perform the same algorithm of divide and merge on these 4? I can. So what I'll do is I'll again start, because now it's the right half's turn to get sorted. So I'll not again divide the 4 elements. And if there are even elements, how do they get divided? Into equal number of elements. So it will become 5, 2 and 6, 4. 5, 2 will become 5, 2. So again, can I say they will be sorted back into 2, 5. And now this one will take place. So it'll be like 6, 4. Again, it will come back. I'll say 4, 6. Perfect. Now, can I say this portion is sorted? This portion is sorted. So now they will come back. And how will they come back? Let's write it out. 2, 5, 4, 6. So both of them will get merged into how many elements?
4.
4 elements. 2 or 4? Which one
first.
goes at the first?
2.
2. 4 or 5?
4.
4 or 5? 4. Sorry.
5.
Now, 6 or 5? Yes. 5. Next 6. It's like 2, 4, 5, 6. Very simple. So this becomes 2, 4, 5, 6. We can go ahead and erase this as well. Got a bit clumsier, but I'm assuming you're getting the explanation. Now, where are we? Can I say we went to the left, we got everything sorted. We went to the right, we got everything sorted. The left 5 elements are sorted. The right 4 elements are sorted. What is that we need to do? We need to merge them. We need to perform the last step, that is merge. So these 1, 1, 2, 3, 4. 1, 1, 2, 3, 4. And on the right, we have 2, 4, 5, 6. We have 2, 4, 5, 6. They will get merged into 9 elements, and that will be my ultimate sorted array. How do we merge? Let's now understand the algorithm in depth. So what we do is, we keep couple of pointers. One here, one here. Okay? And then we create an array of size, let's say 9. 1, 2, 3, 4, 5, 6. We created an array of size 9, or you can create an empty array and keep on piling it up. That's your choice. We will take care of that during the implementation. So we know this entire left array is sorted. We know the entire right array is sorted. So we have to combine them to get a sorted array. So out of 1 and out of 2, because both of them are smallest, I know I've taken the 2 smallest guys from left, from right. Which one will take this place? You say 1. So you take 1 and you place it. And the moment you've taken someone, you'll just move the pointer. Let's start moving the pointer. Got it? And you take 1 or you take 2. Again, you take 1 and you move the pointer. You take 2 or you take 2. You can take 2 and you can move the pointer. You'll take 3 or you'll take 2. You'll take 2 and you'll move the pointer. Now, will you take 4? Will you take 3? You'll take 3 and you'll move the pointer. Now, will you take 4 or will you take 4? You can take 4 and you can move the pointer.
I will take both.
So we can say the left array has been exhausted. Please hear me properly. I can say that the left array is completed. It doesn't have any more elements that can go over here. So
जो
what
एरे
I
है
will
वहां
do
से
is,
कॉपी करके इसमें
without doing any further comparisons, I'll pick up everyone from the right and I'll just put it over here. I'll pick up everyone from the right and I'll put it over here because there is no one left on the left. Got it? If something similar happened, that the right element got completed, then you would have taken this and you'd have put it in. Doesn't matter. So it's very simple. If I have to define the merge algorithm, it's very simple. You take two pointers, compare, put. One gets completed, the other one gets put. We will implement this, do not worry. So we have done this thing. So the last step, what will happen? They come back, and this will be 1, 1, 2, 2, 3, 4, 1, 1, 2, 2, 3, 4, 4, 5, 6. 4, 4, 5, 6. So can I say, after I have completed all the steps of divide and merge, if you carefully notice, the last step was merge in the entire algorithm. So once I performed both of them completely on all the parts of the array that I get will always be sorted. This was the algorithm. I hope you have understood the explanation. Okay, so I hope you have understood the explanation. It's time to understand the pseudocode. The first thing that we have to observe is, what are we doing? We are dividing. We are dividing the array into two halves. But logically speaking, if you're going to break the array down into two new arrays, and then again this array into two new arrays, again this array into two new arrays, will it make sense? No. This is where in the pseudocode we will try to play around with index instead of breaking.
ठीक है, देखते हैं इसको. हमें करना था सॉर्ट लिंक लिस्ट के लिए. इसका ब्रूट फोर्स अप्रोच तो है अपने पास. ब्रूट अप्रोच में क्या करना है? ब्रूट अप्रोच में कुछ नहीं, एक एक्सटर्नल डेटा स्ट्रक्चर लेंगे, एरे लिस्ट. सारे लिंक लिस्ट के सारे नोड्स को इटरेट करेंगे, उसके वैल्यूज को हम अपने एरे लिस्ट में डाल देंगे, और बस एरे लिस्ट को मेथड फंक्शन यूज़ करके या कोई भी एल्गोरिथम यूज़ करके शॉर्ट कर देंगे. बस उसके बाद क्या, शॉर्ट हो गया तो एक एक करके एलिमेंट गेट करेंगे, और इटरेट, जो इस नोड को इटरेट करेंगे उस नोड के वैल्यू को गेट वैल्यू से रिप्लेस कर देंगे, और रिमूव nth नोड फ्रॉम द बैक ऑफ द लिंक लिस्ट. तो इसके ब्रूट अप्रोच हो सकता है ये कि हमें 1 2 3 4 5 दिया हुआ है और n इज इक्वल्स टू 2 दिया हुआ है, तो पीछे से हम दूसरा एलिमेंट, टेल से जो दूसरा एलिमेंट है उसको डिलीट कर देंगे. इन वेयर इज द टेल इज एन इनक्लूसिव. तो मतलब हुआ इसका ये, बेसिकली इसका मतलब ये हुआ कि जब n इज इक्वल्स टू 2 होगा तो लेंथ ऑफ लिंक लिस्ट निकालेंगे, 5 हो जाएगा, और हम इसमें माइनस n करेंगे तो कितना हो जाएगा, 5 माइनस n 3 हो जाएगा. ऐसे करते हैं, मेरे पास 1 है, 2 है, 3 है, 4 है, 5 है, और n इज इक्वल्स टू 2 दिया हुआ है. n इज इक्वल्स टू 2 दिया हुआ है तो हम यहाँ पे बोल रहा है फोर्थ को हमें डिलीट करना है, फोर्थ को डिलीट करना है. तो लेंथ ऑफ द लिंक लिस्ट 5 आ गया. हम न्यू n कैलकुलेट कर सकते हैं. न्यू n क्या होगा, लेंथ ऑफ द लिंक लिस्ट 5 माइनस n का लेंथ, n जो वैल्यू दी हुई है 2 विच इज इक्वल टू 3, इसमें प्लस 1 कर देंगे, ये आ जाएगा 4. बस आगे से लिंक लिस्ट को इटरेट करेंगे, और जब हमें 3 पॉइंटर की ज़रूरत पड़ेगी, 3 पॉइंटर्स की ज़रूरत पड़ेगी, नहीं 2 पॉइंटर्स की ज़रूरत पड़ेगी, एक टेम्पररी इटरेट करने के लिए और एक प्रीवियस. जो टेम्पररी जब नेक्स्ट होने से पहले प्रीवियस टेम्पररी को होल्ड करेगा. तो इंट i इज इक्वल्स टू 0 और वाइल लूप लगेगा, टेम्प इज नॉट इक्वल टू नल, और काउंटर बढ़ाएंगे. जब i इज, जब न्यू n, जब हाँ i इज इक्वल्स टू न्यू n हो जाएगा तो क्या होगा, हम रिटर्न करेंगे जब I इज इक्वल्स टू न्यू n हो जाएगा तो हम बोलेंगे प्रेव अपने नेक्स्ट में तुम नेक्स्ट प्रेव का नेक्स्ट रख लो और क्या और अगर न्यू n के इक्वल नहीं है तो न्यू n के इक्वल नहीं है तो फिर prev is equals to temporary और temporary is equal to temporary dot next ये हो जाएगा और बाहर आके cannot read field next because local 70 is null अगर हम प्रीवियस को भी हेड से इनिशियलाइज करते हैं तो काम अपना बनेगा क्या लेट्स चेक इसको भी हेड से इनिशियलाइज करते टेम्परेरी इज नॉट इक्वल टू नल I प्लस प्लस I is equals to new n which is 1 is equals to 1 prev connects head connects ये भी फिर भी नल पॉइंट एक्सेप्शन देगा तो नेक्स्ट के नेक्स्ट में सर्च करेगा इसकी फट जाएगी फैन इज इक्वल्स टू 1 होगा तो रिटर्न कर देंगे हेड डॉट नेक्स्ट, नहीं तो ये करेंगे। वेट वेट वेट